So the Liskov substitution design principle states that object of a superclass shall be replaceable with objects of its subclasses without breaking the application. So we will be learning this design principle. Let's take an example. For example, we have a parent class, and parent class has method show and test, right? And it has two child class, child 1 and child 2, right? Now here, for example, I am I am making object of parent class p1 equals to new child 1. For example, I'm replacing the object of parent with child's object, and if I call p1 dot show or p1 dot test, the functionality shouldn't be break, so there should not be any problem with calling show and test method. Or take an example of parent pay2 equals to new child 2. For example, now we are replacing the parent's object with child's object, that is child 2. And if I am calling p2 dot show and p2 dot test, and the whole functionality should not be break. So this is what Liskov substitution design principle states. Objects of superclass shall be replaceable with objects of subclass without breaking the application. So now we will be making the real example. For example, I have a class bird in source package. Okay, I am creating class bird, and in this class we have two methods. One is public void walk, and another method we have public void fly, and we are printing bird is flying here, right? And from this class I'm creating one class parrot extends bird. Now parrot is inheriting both the methods here, walk and fly. Similarly, I am creating another class penguin extends bird. Now we know penguin cannot fly, so we'll be overriding the method fly here, and I will be returning new unsupported operation exception, penguin cannot fly. Sorry, throw new unsupported operation exception, penguin cannot fly. Now for example, I have a main class, here if I am making object of bird b1 equals to new parrot, and for parrot I can call b1 dot walk, b1 dot fly. So if I run this, so by using the object of child class, so we can see both the functions executed successfully. Bird is flying, bird is walking. But if I make the object of penguin class, which is also a bird, and b2 dot walk and b2 dot fly. So as we have overridden the fly method for penguin class, and which throws the exception penguin cannot fly. So if I run this program, so we get this exception, unspotted operation exception, penguin cannot fly. So which is breaking the Liskov substitution principle. So here we have mentioned, if we are replacing the superclass object with subclass object, the functionality shouldn't be break. But here, because of the bad design, we are just breaking the functionality. So this is not a good approach. So just to rectify this, so we will have to make some changes in this example. So in the parent class, we will be keeping the common methods which are applicable for all the child classes. So for example, fly method is causing the problem. So what we will be making, okay, let me do one thing. I am making one package that is bad design package, and let me copy all these classes in this bad package. And now let's make another package that is for good design, which will follow the Liskov substitution design principle. Here we have one bird class and public void walk, because all the birds can walk. So this is the common method we kept here. I am making another class that is flying bird. So here we will making this inheritance and public void fly method bird flying. So now what we will be doing, for example, I am making class parrot, so which is a flying bird. So we will be inheriting it from flying bird, so which contains both walk and fly method. But if I take the example of penguin class, so let's declare penguin class, we will be inheriting it from bird class, and which contains only walk method, right? And if I am declaring in main class, for example, we are making a bird b1 equals to new penguin, and now it has access of walk method only, right? Because parent class contains only walk method. And if I am making flying bird equals to new parrot, which is of type flying bird, and for b2 we have access of both fly and walk methods, so we can call walk, we can call fly method. So now in this case, so there is so now in this case there is no exception. So let me just correct the printing in walk method. So bird is walking, and now you can see as per the parent, so bird class have access of walk method only, and using the child object penguin, so we can call walk. And for flying bird we have access of both walk and fly methods. So hence you can see we are clearly following the Liskov substitution principle, and it is not breaking the functionality. So whatever the methods a parent class can have, the same methods we are accessing through the child class. So I hope this example just make this clear, like how we can implement Liskov substitution principle. If you have any further question, you can comment, and let's meet in next video of next solid design principle. Thank you so much.